So this presentation will run through some of the basic concepts of VIPM. And for those of you that don't have experience with VIPM, it'll go through some of the professional features and an overview of the product. So what is VIPM? So VIPM, first and foremost, is a deployment solution for LabVIEW code modules and add-ons. It's also a system configuration management tool. With VIPM, you can also create networked repositories and do remote system updates. VIPM has also been adapted by National Instruments as the standard for deploying LabVIEW tools and add-ons. It actually is the backend and what powers the LabVIEW tools network. And we're very proud to say that VIPM also ships with LabVIEW. So why use VIPM? So VIPM delivers add-ons, tools, and code modules to LabVIEW software teams in a form that is natural to them. And so VIPM integrates well with LabVIEW. For example, if you have add-ons that were packaged with VIPM and installed with VIPM, you can create tools that install file menu items into LabVIEW. You can add menu items into the tools menu. And you can see here at the bottom that there are some add-on tools that are already showing here. For example, MGI tools, Neural ID, etc. You can also help add documentation into the help menu of LabVIEW using the install capability of VI Package Manager. But first and foremost, VIPM creates add-ons that can install into the palettes. If you're creating for the LabVIEW Tools Network, the standards say that you can create add-ons, create tools into the add-ons palette. But if you're creating tools internally for your company, you can also have a custom category at the root level with your company name, and you can have all your reuse libraries organized in one place. And when your tools are in the palettes, you can use features such as Quick Drop, which once you start searching with Quick Drop, it automatically pulls everything from the palettes. And also we support RT and FPGA palettes because each of those environments has their own custom palette, and you can target those as well with VIPM. The LabVIEW Tools Network is accessible through the LabVIEW 2012 UI. There's a Find LabVIEW Add-ons link, so when you click on that, it opens up the VIPM LabVIEW Tools Network window. And this is how you can browse various add-ons for LabVIEW. If you use the search capability in the search box, it'll actually pull up, it'll search the descriptions and various keywords that are built into the network. So what is the VIPM package deployment process? So we're just going to go through an overview right now. So first of all, you create your reuse source project, and that could be selecting existing reusable code. It could be from an existing project, or you could import third-party instrument drivers, or you can be creating new tools from scratch, whether you have a template that you start off with, or just a blank VI, you can do that. So at some point, you have to have the reusable code. Your source code editing is the same as before. VIPM is not intended to replace source code control. It's intended to package the products of your source development. So you can make changes and improvements to your source code, update your code, commit it to source code control of your favorite platform. And when you're done that, you can build a package. So building a package is analogous to building a special type of installer. And that is, a package is a format that's compatible, is recognizable by LabVIEW, and it contains information in it and instructions on how to install your add-on into the LabVIEW development environment. It contains information about the palettes, what version of the add-on you've created. Various system requirements. You can specify requirements such as a specific LabVIEW version, a specific OS. You can include a license agreement and various custom actions. And we'll get into those in a little bit more detail later. Now, once you've built this package file, what do you do with it? Well, you have to install it. So once you install it into LabVIEW, it could go into VILib, userlib. You can upgrade or downgrade previous versions. During the install process, VIPM does mass compiling. And in addition to that, you can install various system components during the install process. And if you need to make changes to your reusable code, your add-on, you basically go back to the left side and edit your code here and repackage it and distribute it. So I'm going to do a little bit of a small demo of packaging. And I'm going to create a package of reusable code using our importing of a third-party driver. So a new feature in VIPM, which we just released recently, is the ability to import third-party drivers. And here I've loaded up the instrument driver network on NI's website. And I'll just click one of the drivers that are available. So this is the Ocean Optics driver. I'll click on that. And down at the bottom, I'll select the LabVIEW 2010 version because that's the most recent. And I'll save it to a special folder I created called IDNet download. I'll do that. And you'll notice that it's a zip file. So if you take a look at this zip file, inside of it, it contains the source and the code. And basically, instructions are not really included here. So you have to understand how to install it. And also, it doesn't integrate well with versioning. So once the installation process requires you to copy that into your source folder, and then uninstalling requires you to delete that code. So it's a little bit difficult to manage, but through VIPM, we'll show you how to make it easier. We'll go into VIPM package builder. And from the tools menu, we select import IDNet instrument driver. This just gives you an overview of what's going to happen. And we say yes. So I'll pick this zip file. And now it's asking me for a target folder. Now this is the location where my source code will be, where I can in the future edit it or commit it to source code control if I want to. So I just have a folder next to it called export. I'll select that. And right now it goes through and processes the IDNet driver and converts it into a format that VI Package Manager, VI Package Builder can accept. So only take a few seconds. Okay, so now we have the option to either build the package right away, but we're going to skip that for now, and we'll just say View Settings. So what we see here is VI Package Builder interface, which has been pre-populated with all the information from the IDNet driver. So here's my source folder. This is where the package will be built, and this is the version number. And it's imported all the release notes as well. So before we build, let's just go through some of the interface here. I'll show you the most important part, which is the palettes, and this is how you edit your palettes. So here in the palette section, there's the function palette, and you'll see that it's imported it, the driver information with the icons and all that. And if I click on this, I can drill down into the palettes and see all my VIs and icons. Now, palette editing is a lot easier in VIPM than it is in sort of manually through the LabVIEW interface. If I hold down the control key and click on one of these subpalettes, it'll open up another palette. I can just hit down the control key and click, and it'll open another one. So now I can see multiple of them in parallel, and I can drag items between each one. So let's say I want this one to show up at the root level. I can just drag it over, and now it shows up in there. And I can shift things over like that. Editing of icons is easy. I can right click and say edit icon. And that's how palette editing is done with VI Package Builder. So let's go ahead and build this package. So while that's working, let's just go through some of the other features of package building. So we mentioned the general information window, and that's where you can add release notes and your versioning is controlled. For display information, you can include a license agreement, which could be your company's license agreement. You can have a link to your website, which shows up in the VIPM user interface. And you can create a product description, which as well shows up in the VIPM interface. We described a little bit about palettes. Here at the top area, you can see where it says custom category. And this is where you can define your own category. For example, company category where your palettes can go under. VIPM allows you to define your destinations or where your tool gets installed. These are physical folders on disk. So here, this is the root one, which is the main installation folder, and that could be VILib or it could be user lib, it could be instrument lib or wherever you want your root tool to go to. You can manipulate individual files, and you can add password protection. You can add prefix or suffix dynamically during the build process. Custom action section. Now, this is a powerful area where you can expand the capabilities of VI Package Builder, VIPM in general. During the build process of the package, you can do tasks before or after the build process, and that's with a pre-build or post-build VI. And these are basically VIs that are that you create, and then VIPM executes these VIs during these different phases of the build process. And these could be custom actions such as, deleting temp files or renaming files or whatever you want to do, or creating a copy of the output and putting it somewhere else, or uploading it to source code control or whatever you want to do. Now, install and uninstall actions are things that get packaged in with your package, and these get executed on the user's target machine during the install and uninstall process. And there's before install, after install, before uninstall, and after uninstall. So let's check on the build process here. Okay, so it looks like it's done. And here you can now open it in VIPM, which will open the description of VIPM and allow you to install it and test it out, see if it works. You can show the package in File Explorer and just take a look at it. Or you can publish it to a repository. And what repositories allow you to do is you can take this package, put it on a shared location, and then VIPM can connect to it and automatically check for updates on this package. So before we publish, we'll just take a look at it right now. So just open in VIPM. And this is what the end user will see when they try to install your package. They'll see this description window, and here are all the descriptions that we had. Of course, we haven't done anything to the driver itself. This is just original imported. We haven't modified the code or anything. But if we wanted to, we could. And that's how it looks like. And then you can pick your LabVIEW version. Right now, I've only enabled 2012, but I could have multiple versions here, and then you install it. I'll just close this for now. Go back into the driver area of the destination. So here you can see where The destination is targeted instrument lib, but I can change this if I want to. And that's how you would change the target location. If you want to change where the palettes go, you would actually change that here. So that's independent of the folder on disk. So you would click on this browse button and it would browse and it would show you a tree of your palettes and then you would pick it. So right now, by default, it's installed into the instrument IO palette, but you can change that if you want. So let's publish to a repository. So I can either publish it from the dialog or I can hit publish from here. So I will, right now it's, I don't have a repository set up, so it's asking me to do that. So I'll do that. I'll pick a folder which is actually shared on Dropbox. And I'll explain how this works in a second. But for now, I'll just pick this Dropbox public VIPM public demo. I'll select the current folder. I'll just call it that. Now it's asking me if I want to publish this package, which I just built. I'll just say yes, and that's it. So now what I've done is I've created a folder on disk, which is shared with Dropbox, and I've published that that package. Now someone that's on another computer on the network can actually connect to that repository via a URL that I will give them. I can look at my repository if I want to, and that's, you can see that it's located there. By clicking on the repository button, I can see my package being published. So if I want to share that URL, I'll have to go into on disk and look at my repository. So here we see the repository, which contains a collection of files. And before I can do that, I need to find the URL of the repository, the public URL. And because I'm using Dropbox, the way to do that in Dropbox is you can right-click one of these folders, one of these files, any of them, and go to Dropbox, copy public link. And I go into my repository configuration, so my repository itself, and go into repository properties. And right now, VIPM defaults the public URL to the local folder, which is what it is. But I can change that to a public one, which is that. So now that is my public URL that I will share with other people. And it also generates an RSS URL, which I can actually give to someone if they want to subscribe to the repository via RSS. So I'll just remember that URL, say OK. So that's on the publishing side, all I need to do. So now let's imagine that we're on the client side now, and the client wants to subscribe to our repository and get our package. So on the client side, you would go into Tools, Options, Network, and you would add a subscription to that repository. So I'll just click on the plus button, and I'll put that public URL, which I was given, and just say OK. And now I'm subscribed to that repository. I just hit OK. And VIPM checks the repository and does a refresh to see if there's anything new. And now you'll see that at the top of the list here, there's a repository called VIPM Public Demo. And it's the Ocean Optics driver. If I double click on that, I will see the description of that driver that I published. Now, right now, there's only one version, and I can install it. If there were multiple versions, I would be able to see those. Let's see, give you an example of some other packages that have multiple versions. Like, for example, the OpenG application control library, you can see all the different versions here. And if I had multiple versions of my driver, I would see the same thing. So every time I publish a new version, I would see that there. So now let's install this. So I can just hit the install button from here, or I can hit the install button from the properties window. So I'll do that. And you'll see it connects to Dropbox and downloads the package. It extracts it. That's it. And if I go into LabVIEW and right click on Instrument IO drivers, you'll see that the Ocean Optics driver, which I created, is there. Now, if I wanted to add other items to my repository, not from the package building window, but just publish new packages, I can also do that. I can go into the repository manager. Right now, I only have one package here, but I can just add them through by hitting the plus key here. And I can just add it that way. I believe I can add multiple as well. Here's some other drivers I've created. Multiple packages. And that's it. Now, behind the scenes, what happens is, of course, you're publishing stuff locally, and then your Dropbox handles the synchronization between your computer and the remote server. If you're using a company repository, you would probably use a local server, and then you could either publish directly to that server instead of on your local hard drive, or you could use, if you're not using Dropbox, you can use FTP in the background to upload things to an FTP site, or any way that you can get things remotely. The reason I'm using Dropbox is it's a free tool that everybody can try out and use. Now, I've published those things. If I do a refresh here, check for updates, it checks for updates, and then if I scroll to the top, I see all the packages that I just added in this list that are new in the repository. So we build packages with VIPM. We have a network repository, which we use to publish. We have a client, which is also VIPM, and you can subscribe to these repositories. But you can have multiple people publishing to either the same or parallel repositories. So you can have a single person subscribing to multiple repositories, or you can have one person publishing to multiple repositories. As I mentioned, it could be an internal or external server. And the repository files, it doesn't require any server-side smartness. You don't have to have special code running on the server. It's just basically a collection of files which get located somewhere. And so basically, because they're just files, they support any kind of corporate backup system that you have in place. Clients can be, of course, anybody who's running VIPM. And they could be contractors, or they could be developers internally. It could be various test systems or test stations. Test stations can be VIPM clients that connect to updates on a repository. The key here is that you can easily install and uninstall a component of reuse. And each component is packaged in a package, and those have version numbers. So that's how you can quickly switch between different reuse libraries and by using versions and versioning. But we've taken this to another level in VIPM, in that in addition to just having versions and packages themselves, they can also have dependencies. So you can declare that, for example, instrument driver depends on a subcomponent database interface API, for example, a specific version of that component. And you can also declare conflicts where one package cannot be installed with a specific version of a package. And this allows you better modular control of your reuse library. And also, if multiple high-level packages are using the same component, if you fix a bug in one component, then all the high-level packages automatically get that fix for free. And it allows development of these components to be distributed among different developers. In addition to publishing packages, you can also deprecate them. The action of deleting the package from a repository is called unpublishing, and that basically removes it from the repository completely. But if you just deprecate it, it's actually preferred because some of your legacy code might still depend on an old version of a package. So you want that to still be in the repository, but not available to new users. So that's why you want to just keep it in there, but just deprecate it so that your old code still can link to it. Now, one other feature of VIPM is configuration management of your packages. Now, if you start building a lot of packages, then you will have an issue where you need to know what versions of the packages are being used by your project. You have an instrument driver, you have interface to a database, you have a special math algorithm. So these are 3 packages that a specific project or a system uses. How do you configure these, or how do you configure your system or make sure that your system has these installed? Well, we've come up with a system called package configurations. And what these are single files that wrap specific versions of packages inside of it. So it's called a VIPC file, and it's a configuration that either can contain a reference to the a reference to the package, or can contain the package itself. So the package can be inside this other file. And the way you use it is you apply a configuration to make sure the correct VI versions are installed. It contains all the packages of a specific version by a project. Like I mentioned, it can take a reference or the actual package. And if it's a reference to a package, then VIPM looks at all available repositories to see if that package exists. And if it does, it downloads it automatically from whatever repository is available. The benefit of not having the package in the VIPC file is that the VIPC file is smaller, but that's the main benefit. I'll just go through a short demo of this. So I'll open a project in LabVIEW, and this project, what I've done is I've included a VIPC file in it. And if I open the main VI, you'll see that it's searching for a specific driver, which is missing. If I ignore all and show block diagram, you'll see that it has question marks on the diagram. And this is because a reuse library that this VI depends on is missing. Now, if I double click on the VIPC file, okay, so what happens is VIPM opens that VIPC file and it just shows you the content. So these are all the dependencies. These are all the reuse libraries that my project uses. And what I can do is I can apply this. So I'll just do that by clicking on this here. And what VIPM does is it goes through this list of dependencies and determines which one is not installed on my system and installs that one. And it found that this one is not installed, and it just say continue. So now if I open this main VI, you'll see that it's not broken because the dependencies are installed. And that's just a quick use case of showing you how you can use configuration files with your projects to maintain your configuration. From the package configuration window, if you want to find out what packages your project is currently using, so let's say you just create a project and you're just, all willy-nilly just using various add-on tools that were packages. And now, so you don't really know what reuse libraries you are using. Well, you open up a blank VI package configuration and hit this scan button, and it'll actually ask you to point to an LV proj file or a project folder or a top-level VI, and it will actually scan your hierarchy and find out all your reuse libraries and add them in here, and then you can save them. And then you can add that VIPC file into your project. So that concludes kind of the overview of VIPM. Hopefully I've given you some ideas of how you can use VIPM in your company and how VIPM is useful to you. There are two versions of VIPM. There's a free and a pro. In the free version, you can install packages. You can build packages freely. In the pro version, you can publish to repositories. You can subscribe to repositories. The LabVIEW Tools Network subscription is built in and is free. You don't have to pay to connect to the LabVIEW Tools Network. Importing of third-party IDNet drivers, that's a pro feature. Creating package configurations, and also another feature which I didn't mention is a more advanced, but you can actually control VIPM with a VI-based API. So if you want to create tools that programmatically do the things I just showed you, you can do that. For more information, you can go to jki.net/VIPM, and all the pro features can be activated and tried out with a 30-day trial. Thank you for your time.